Alright, the nth test for divergence. Basically what theorem 7 says is that if we have an infinite series and it converges, we know from that that it's absolutely necessary that the nth term as n goes to infinity is going to 0. Okay, so if this converges, this must be true. Otherwise, we would be adding something that's non-zero n to infinity, and that would always diverge. Now, that's one way of thinking about it, all right? And that's what theorem 7 says. But I want you to be aware of that causality goes in this direction. If it converges, a to the nth must go to 0. A sub n goes to 0. However, this way does not work. Just because the nth term of the series is going to 0 as n goes to infinity does not mean that this series converges. And that's why in the next little box they talk about the nth term test for not convergence but divergence. What does that mean? It means that if you do a test and you find that a sub n is not going to 0, then your series must diverge. Okay? Maybe some examples to help this out. If we had a series that, this is pretty obvious, but I'll just do it, n squared. Okay? Well, obviously that series is going to be 1 plus 2 times 2 is 4 plus 9 plus 16. The nth term is most certainly not going to 0. In fact, it's going rather rapidly to infinity. Therefore, this sum, this series, must diverge. And that is the classic way to use the nth term test for divergence. But let's now consider the case back up here, what theorem 7 is saying about a to the n is actually going to 0, a more interesting case. Let's consider two of them. First one, n equals 1 to infinity of 1 over n squared. This is an example that we worked already. Clearly, the nth term as n goes to infinity is going to 0 because at a limit 1 over n squared is going to 0, and that if we worked out the math, this converges. Okay? However, if we look at a very similar case, and in fact we know it converges, what is it, 2? Something like that. N equals 1 to infinity. Very similar equation, 1 over n. Now, at a limit, as n goes to infinity, does 1 over n go to 0? Absolutely. Okay? So this does go to 0. That's still true. But if we, in fact, I think we'll work this out later, this diverges, goes to infinity. Okay? So what we see is when we say this first series converges, we know therefore the nth term must do this. If it diverges, we really don't know anything about what the nth term is going to do. Okay? So just remember this. This is a test for divergence. If the nth term does not go to 0, it must diverge. If it does go to 0, the series may converge or it may diverge. You don't really know. You'll have to do other tests.